So somebody asked me, how do you find outliers? So I've got two different kinds of data here, and I want to show you both of them. And so this is a set of I don't know how many cereals, 49 brands of different kind of cereal, and I've got them ranked by the percent of sugar. Shredded wheat's only 1% sugar, and sugar smacks, or what do they call them now? Honey smacks or something like that, 60% sugar. So I said, well, that's kind of varied. Let's take a look at the graph. So I used a set of software and generated a box plot, and I generated a histogram, and I noticed that these both are looking right skewed to me. See how the tail goes off to the right? Here, let me get a spotlight. See how the tail goes off to the right, and you can kind of see it in the box plot how this end is so much spread out. 50% of the data is captured there, where it took this far to get 50% in the upper half. So definitely a right skewed distribution. So because this is a skewed distribution, we need to be we're going to talk about the center by using the median, and any kind of spread for the data, will you use the IQR or the 5-number summary, how the way I want it. We're going to use the IQR to find outliers, so that's why I said let's use IQR for the spread. So skewed distributions, median, IQR, shape, center, spread. So since this is a skewed distribution, we're going to use that 1.5 IQR outlier test to look for unusual values, right? So I took the quartiles. There's the lower quartile, there's the upper quartile, and then I found the IQR. Actually, the software gave me the IQR, subtracted those two. Now we want to find 1.5 times that IQR, which is this one. Then to get the lower cutoff, the lower fence, we took Q3. Here, let me do this visually so you can see. This might help you. What I'm basically doing, I'm running a 1.5 IQR test. Here's the IQR, right? At that distance. So I'm going to take 1.5 of those. So let's see. Let's go red. Let's see. I wish I had graph paper. Probably should have done this in graph paper. Let's call that 1.5 of those. Probably not quite. And I subtracted that from the lower quartile. And notice when I did that, I got a lower fence cutoff of negative 48% sugar, which is outside the data and doesn't even make sense. So there's no lower outliers in the data set. Now we'll do the same thing with the upper fence. We're going to take that same distance, that 1.5 IQRs, and it's going to be up there. I don't know, about that far, maybe. I don't know. And that's up above the the maximum value. So there's no upper outliers either. So even though this is a pretty varied data set, it doesn't appear to be any outliers in it based on this test. Okay, and so what did I do to calculate that upper fence? I took the upper quartile Q3 and I added that 1.5 IQR figures. Okay, so no outliers in this data set using the appropriate measure of center and spread. I mean, we could certainly go do this with the 2 standard deviations away from the mean, but we shouldn't be talking mean with this data set, okay? So somebody wanted to argue that sugar smacks are, oh gosh, Captain Crunch, my favorite. Captain Crunch is too high. Well, we couldn't say that it's far enough away to say that it's unusually high. Tasted it is, but okay. So that's for a skewed distribution, how you find the outliers. Now the other set of data I came across this is cholesterol levels in non-smokers, and they sampled 34, 33 ex-smokers, and they came up with so then I could, well, what's the shape of it? So I use that same software to make a box plot and a histogram. It's not perfectly symmetric, but it's not looking half bad. So I said, well, the other thing we like to talk about is when we're trying to make a decision about the shape, and since this one's a little weird, let's take a look at the median. Let's take a look at the median and the mean. Well, they're within 5 points, which is within 2%. So to do what Dr. Stevens did with the jeans and the khakis or the state university versus the state college dropout rates when they're talking to those percent greater. So um, the median's only 2% greater than the upper quartile. Now, what am I trying to do? The median is only 2% greater than the median. So I think that this is close enough to speak. These are close enough to say that they're close enough, and that we're going to call this a symmetric distribution. Okay. So because this is a symmetric distribution, I want to use the mean to talk about the center. I want to use the standard deviation to talk about the spread. If you start getting confused about, or if you're confused about, well, why can't I use the IQR or the 5-number summary and the mean, or why can't I use the median and the standard deviation? We use the mean to calculate the standard deviation, so we don't want to talk about the center or the median if that's the case. Okay, so and conversely, you find the IQR by using the 5-number summary, which is part of the median is part of that. So mean and standard deviation and married. Don't mix them up. Don't use those together. Use the median and the IQR, or median and the 5-number summary. Use those together. Don't mix and match. Okay. So because we're using the mean and the standard deviation, we are going to use the two standard deviation away from the mean test. So I took the mean and I doubled the standard deviation and I subtracted that from the mean. I got 137 as the lower fence. We had no lower. We did have somebody. I didn't think about that. So that person with 134 cholesterol level, that's lower than the lower fence. So we could consider this an outlier. This person has unusually low cholesterol compared to the rest of ex-smokers. And then the upper fence, I did the mean plus 2 standard deviations. That's 328. And I think that's higher than 328 is exactly the highest, but our upper fence is just beyond it. So we couldn't consider that an outlier. So this data set does have one outlier. That 134 is an outlier based on this 2 standard deviation test. Okay, I hope this answers your question about how do you figure outliers. It depends on the shape of the distribution, and then you use one of the 2 tests. Okay, we're really where we're going in the rest of this course is we're going to leave the skewed distributions behind, and there's some tricks that happen that everything's normal. It's great. Well, and if it's not normal, then we got to go back and do some other stuff. Okay, so that's beyond, that's a stat 2 question. We're going to be dealing with normal distributions. Okay, and if they aren't normal, then we're going to have to say, well, we can't do this. Here it is, but this isn't really right. Okay, so I hope that answers your question.